Hello, everybody. Okay. This video is all about implicit derivatives. So we're getting into sort of the meat of Unit 3 in this video. And the thing that you need to understand first and foremost is when to use implicit derivative techniques and when it's unnecessary. So before this current lesson, every function that we've done before this had the following. It was y equals some function of x. In other words, what was over here was nothing but x's, and the y was specifically solved for. The y was by itself on one side, and all the x's were on the other. So if you're able to look at something like this and solve for y, in other words, you look at something like this and then you do some algebra and turn it into something like this, if you're able to do that, then you don't have to use implicit derivatives. However, in this particular example, I can guarantee that you will not be able to do that. And when you're not able to do that, and you still have to find a derivative, then we use the technique of what's called implicit differentiation. Okay. So let me write that down. Yeah, implicit differentiation. Okay. Awesome. So here's how this works, right? So basically, there's just a few things that we need to keep in mind. What we're typically doing is we're doing d by dx. In other words, we're taking the derivative with respect to x, not usually y. We can do d by dy. There's nothing wrong with that. But typically in this course, AP Calculus or Calculus 1, we're almost always doing the derivative with respect to x. So let's keep that in mind. This is the derivative operator, and here's something that you should already know: dx is 1. Okay, let's remember that dx is 1. And, dy dx, that's literally just the first derivative of f. Okay? And getting dy dx is our goal. So let's use all this in conjunction with the rules that we've already learned: product rule, quotient rule, chain rule. And let's see if we can find the derivative of this expression here. So here we go. First thing to realize, this is a product. X squared times y. So since we have a product, we have to use, you guessed it, the product rule. Also here's a product as well. So if you use the product rule here too. We don't have to use it here. We don't have to use it here. Don't have to use it here. Don't have to use it here. Okay. So it's good to look at the expression and sort of think about how you're going to attack the problem. Think about where the products are, think about where the quotients are, and don't forget the chain rule, right? So here we go. Let's work with this piece first. So we have x squared times y. So we're going to use the product rule, right? Let me write the product rule. So the product rule is just that, right? You take the derivative of one of them, leave the other one alone, and then plus, and then take the derivative of the other one, leave the first one alone. Okay. So essentially, for this first little term here, my f is like x squared, and my g is like y, yeah? So the derivative with respect to x, df dx, is 2x, and this with respect to x is dy dx. Okay, literally what I did, like seriously, is I applied d by dx to both sides. That's what I did. dg dx is g prime, and it's dy dx. Okay? So those are all the pieces. Now, let's write down the derivative of that first bit, right? So the derivative of x squared y with respect to x. So just the first bit here is going to be, well, it's going to be 2x. Take the derivative of the first one, leave the second one alone, plus leave the first one alone, and then take the derivative of the second piece, which is y, so just dy dx. Okay? That's for the first chunk. All right? Let's talk about the second chunk. Second chunk. Very similar. We're still going to use the product rule. So we're doing d by dx of x y squared. Okay? So x is the first piece. The derivative of x is 1. Leave the second piece alone, plus leave the first piece alone, take the derivative of the second piece. So okay, yeah. So this is important. This is the chain rule, okay? Because we have something being squared. What is being squared? Y is being squared. So we have to take care of the square part first. So we bring the exponent down, reduce by 1. And then we go to the inside, which is the variable y. And remember, y is a function of x. So its derivative is just y prime or dy dx. Okay? So y squared plus x 2y dy dx. There we go. So there's those pieces. Those are the hardest pieces of this entire thing. The derivative of this is just going to be 3x squared. The right-hand side, we're just going to have, if we take the derivative, we're going to have dy dx, negative 1, and then nothing. Okay? So we've written down all the pieces, or we've at least mentioned all the pieces. So let's actually do this entire problem now, armed with the knowledge that we need. Okay, so basically, here's what we're doing. We're going to apply d by dx, the derivative operator, to both sides. Okay? This is the fundamental concept of how to do implicit differentiation. So we're going to have x squared y plus xy squared plus x cubed. And then over here on the right, we're going to have y minus x plus 4. Okay. And again, these first two we've already dealt with. Okay. So I'm just gonna write down what we already know. So it's going to be derivative of x squared is 2x and then y plus, leave the x squared alone, and then dy dx. Take the derivative of the second one. Plus now this one. So the derivative of x is 1. Leave the second thing alone, plus leave the first thing alone, and then take the derivative of y squared. And again, we've already done that. 2y, and then go inside the variable y. dy dx. Plus, and then the derivative of x cubed, 3x squared. Okay? There we go. There's the left-hand side. Now the right-hand side, the derivative of y. So just think about applying this to y. You just get dy dx. The derivative of x is 1, but there's a minus, so minus 1. And then the derivative of 4, that's a constant, so no change. So boom, there we go. All right, now, once we get here, and every implicit problem is the same, okay? So stay with me here. Once we get here, we want to put every term So put all dy dx terms on one side so that you can factor it out by greatest common factor, okay? We're going to do that, and then we're going to put all non dy dx terms on the other side. Okay? Once we do that, we can factor dy dx as a greatest common factor on the side that contains all the dy dx terms. And then finally we can use that to solve for dy dx. Okay? So that is what we're going to do. Okay? So let's look at what we have. Does this term involve dy dx? It does not, so it's going to move. Okay? So what I'm going to do is I'm going to show each little step that I'm going to take. Okay? So I'm going to subtract 2xy from both sides. Okay? Boom. Done. This term has dy dx, so I'm going to keep it on the left-hand side. This term, no dy dx, so I'm going to subtract it. Okay? Boom. Done. And then plus x 2y dy dx. It has dy dx, so I'm going to keep it on the left-hand side. Plus 3x squared, no dy dx here, so I'm going to subtract 3x squared from both sides. And there we go. So minus 3x squared. Okay, so let's see what we got now. One more thing, sorry. Right-hand side. So we're looking, boom, here, right-hand side. The right-hand side has this dy dx term. And, we're trying to get all the dy dx terms on one side. So I'm actually going to subtract this from both sides. So minus dy dx. Okay. So let's do this, right? So on the left-hand side, I'm going to have x squared dy dx plus 2xy dy dx and that's going to be it for the left-hand side. Okay, everything, oops, nope. Subtract dy dx from both sides. Remember? I almost forgot. Minus dy dx. And then equals. And now, see what's over here. All the non-dy dx terms. So, -1 minus 2xy. Minus y squared minus 3x squared. I'm sorry, minus y squared minus 3x squared. There we go. Okay, so there's both sides. So now, every term on the left has a dy dx. There's dy dx, there's dy dx, and here it is again. So I'm going to factor that as a greatest common factor on the left-hand side, leaving x squared from the first term plus 2xy from the second term, and then minus 1 from the third term. And I still have all this over here on the right-hand side. Okay. And now I'm solving for dy dx, right? So I'm going to divide both sides by all this nastiness. Like that. just like that. Okay, and then if I do that, boom, boom, goes away. And we wind up with the following. dy dx equals -1 minus 2xy minus y squared minus 3x squared. So many minuses. Over x squared plus 2xy minus 1. And if you hate the minuses, you can factor out a negative and make everything positive. It's just a little easier to look at. Okay, there we go. So this is implicit differentiation, right? This is how we take the derivative of something where y is not solved for directly. Okay? So yeah, there we go. I think I'll probably do some more examples of this as well. So there's that. Blair out.